Okay, so what I want to talk about here is basically, number one, an introduction to MATLAB, and especially as it relates to signal processing, right? And so you're going to be doing a lot of MATLAB in this course, and so I want to make sure that you've at least seen some of it. I'm going to go through kind of basic syntax, especially stuff that you may not have seen before for signal processing, okay? And so one of the most important things about MATLAB is its kind of vector nature, right? So you get so used to doing this in MATLAB that then going back to something like C seems like a chore because you have to do all these for loops, right? So, for example, let's suppose that I have, vector 1 and vector 2, right? So if I want to add these vectors up, all I have to do is x plus y, right? That's easy. Or if I wanted to, square these values, all I have to do is something like x. Okay, so let me actually back up. So the first thing you're going to bump into in MATLAB is the fact that if I try to say, okay, well, what about x times y? Then I get an error, right? The reason is that MATLAB thinks of everything as a matrix. And so you should know from linear algebra, from multiplying matrices together, that I can only multiply matrices when the dimensions of them match up, right? And so in this case, I'm trying to multiply a 1 by 5 vector by a 1 by 5 vector. And so those dimensions don't match up in the middle. What I need to do is I need to transpose one of them to get a sensical answer. If I wanted to get, well, so that depends on what I want, right? So if I want something that's like element by element multiplication, so if I want to multiply the values of x times the values of y, I can say x dot times y. So that dot is very important. That dot means operate element by element, right? You're going to get snagged on that a lot, probably. If I wanted to do more like matrixy stuff, like if I want to talk about the dot product, right? So if I have a 1 by 5 vector and I want to multiply it, I want to dot product it with that vector, then what I could do is just say, well, I want to get a 1 by 1 result, right? So that means I can keep x the way it was, and I can multiply it by the transpose of y. So the transpose of y is y apostrophe, right? So now this is going to be a 5 by 1 vector, and I can talk about x times y transpose. Then I get just a number, right? Because 1 by 5 times 5 by 1 should give me 1 by 1. On the other hand, if I wanted to do the outer product of those things, right? So if I wanted to get a 5 by 5 matrix, I could say, okay, here's my x, here's my y, and if I were to do x transpose times y, then I would get a 5 by 5 result, right? So everything in MATLAB is a matrix, and so that's the thing to remember is that many times you want to do, element by element stuff, and in that case you need the dot, right? Same thing if I try to do like x squared, right? Gives me a complaint that says, okay, you can't square a vector, which is true, right? I can only square either a number or more generally a matrix, right? So if I have a matrix like this, so if I want to separate rows of a matrix, I use semicolon, right? So if I talk about m squared, I can do that because I can multiply that 2 by 2 matrix by itself, right? But this is not the same, obviously, as multiplying things element by element, right? And so if I wanted to multiply things element by element, I would need to use the dot, right? M dot squared would give me, so if I look back at m dot squared actually squares every individual element. And the same thing would apply if I wanted to, square that vector I had in the beginning, right? So multiplication, division, taking things to a power, generally if you want element by element, you need the dot, right? So the same thing is true for division, right? So if I wanted to divide x by y, I'm going to get, what happened there? That gave me an unexpected result. If I want to divide x by y, then I should use the dot to get the element by element response, right? One thing to kind of be aware of is that, again, we use a lot of complex numbers in this class, and so I could also say, okay, I've got, this complex unit j is by default defined in MATLAB as the imaginary unit. So you can see here that it converts j to I. If I define j as something else, then I would have a problem, right? So if I define this and I do that, then I get a real thing. So you have to kind of be careful not to overwrite I and j with stuff that you may need later, right? So I can always clear j, and then I believe it should go back to the way it was, right? And I believe I also, gives you that. So you can use I or j for a variable, but not both if you care about complex number stuff. So I mentioned transpose, right? So definitely a lot of times you have to kind of worry about what the orientation of a matrix is, right? So if I have if I have my x, oops, maybe a good example is y. So if I have y and I do y transpose, that basically just flips rows to columns and vice versa. And the same would apply to matrices, right? So M transpose, well, that was a bad example. So if I have something like this, M transpose flips the rows and the columns. But one thing, again, to be aware of that I didn't actually remember until recently is that if I have a complex vector and I transpose it, not only does it change the orientation, but also changes the sign of the complex part. So that's a little bit tricky, because really, again, MATLAB also kind of assumes that oftentimes we care about dealing with complex numbers. This is called the Hermitian transpose. If you want the regular transpose, again, you need the dot. X dot apostrophe will give me the vector just rotated. Okay? Okay. So usually if you're making a mistake with respect to multiplying two things that you really want the element by element thing, you'll get some sort of error about dimensions don't agree, and that will tell you that you need to do the right thing. Just be careful when you're dealing with matrices, right? So because there's a big difference between m dot squared and m squared, right? Those are not the same thing from a linear algebra perspective, right? So make sure that you know what you want. Okay, so a lot of times you need to make a equally spaced vector, right? So certainly, if I wanted to, I could kind of tediously, make a vector like that myself. But there's also the syntax with this colon. So if I say 0, colon some spacing, then I can get a vector that's equally spaced where the thing that's in the middle of the colon is the amount of spacing, right? And so I can do this, however I want. If the end point is not an even spacing, then I don't go all the way to the end, right? So this comes up a lot. If you're really you're looking for something quick and dirty, another thing that you can do is called Lin Space. And so if I say, okay, I want to get, remember what the syntax is here. I want 100 numbers between 0 and 1, then this x is going to be, exactly that, right? So this is my set of 100 numbers. So that's generally pretty good. You just want to be careful when you do that to look at, if I look at the first few elements, so here I can say, show me the first 5 elements. You can see that actually, since I asked for 100 numbers, the first one being 0 and the last one being 1, actually they're not spaced apart by 0.01, they're spaced apart by 1 over 99, right? So you got to be a little bit careful to make sure that if I wanted to have a exactly even spacing, then I need to have 101 ticks instead of 100 ticks, right? Because I'm specifying the beginning and the end points. Okay, so actually this kind of indicates, again, I can use this colon notation. This is basically telling me if I just said x by itself, I would get all the values, right? And the other bane of MATLAB is the semicolon, right? So usually you'll, at least once a day, type a variable and you get the whole thing spooling out and you don't really want to see the whole variable. If I put a semicolon after any command, it just doesn't display things, right? So if I only want to see part of a vector, right? So I could say, show me, the 3rd through the 8th elements. I could do that. Or I could say, show me every second element from 3 to 17. I could do that. Another thing that is nice in MATLAB is that you don't have to remember how many elements of your vector that you have, right? So you could always just say, show me, the last 5 elements. So end is a keyword in MATLAB that automatically defaults to the last element of the length of that vector. So that's kind of handy to not have to remember that this vector was 101 units long, right? What else to say about this? It's pretty reasonable. Another thing that comes up a lot is kind of conditional or binary vectors, right? So for example, I could say, okay, let me make a, so let me make a random matrix, okay? And now I want to know which elements of this matrix are greater than 5, right? So again, you could use a double for loop to do this, but you could use a single line of MATLAB code to say x greater than 5, right? That gives me a binary matrix where it's 1 where the condition is true and 0 where the condition is false, right? And then I can use that binary thing as a kind of an argument to the matrix. So I can say, okay, now take all the places where x is greater than 5 and turn that number into 100, whatever it was, right? So again, this might take you a few more steps in a language like C, whereas here in MATLAB it's like a one-line command, right? So if you get really good at MATLAB, you can make very compact and concise code that's still, I think, very easy to understand. What else to say here? So if I wanted to be a little bit more fancy, so let's suppose I were to do this, I could kind of store. All right, let's table that for a second before I think about it. So, other special matrices that you may need to make. So maybe I need to make a matrix that is full of zeros, right? That happens a lot. So I just can specify. If I specify one number, I get a square matrix. If I specify two numbers, I get an m by n matrix. And if I look at, I can use the size command to tell me how big a matrix is. I can do the same thing with ones, so I can ask for a matrix full of ones. That happens a lot. I can also talk about a matrix full of random numbers, so I can talk about a random matrix. This will generate for me a matrix of values that are uniformly distributed between 0 and 1. If I want a matrix that involves Gaussian distributed numbers, which may come up a little bit, here I could also ask for a normally distributed random matrix. That gives me both positive and negative values that are basically zero mean unit variance numbers, which is helpful sometimes. So if I've got a vector, so now I can say, okay, I'm going to make a random vector that is 7 units long, right? So I can certainly look for the maximum of this vector, whatever it is, and the minimum. One thing that's good to get used to is you could also find out where that maximum or minimum occurred and apply it later, right? So for example, I could say, okay, not only do I want the maximum, but I can supply this optional second argument of the index to tell me where the maximum of x was, right? So this tells me not only was the maximum value 0.9593, but also it occurred at position 5, right? And that means that I could then use that position for something else. So then I could say m of ind equals 100. So say I wanted to make sure that that element was really big, I could do it like that. Sort also same way. So if I have x here, I could say sort x sorts things from least to greatest. And if I supply an extra command or an extra argument, then not only do I get the sorting, but I also get where did the values come from in the original thing. Remember, this is all recorded, so this is going to be online. You can go back and watch it. Okay, so again, if you do something goofy and you divide by 0, you'll get something infinite. If you divide 0 by 0, you can say it's not a number, right? So MATLAB can't do magic. And then you can also test for if you've got some sort of problem, right? So suppose that I say, okay, I've got some sort of vector, and let's kind of put some of this together. So here, let's make a vector that is from 1 to 10, and okay, that's fine. So now let's say take all the places where x mod 3 is equal to 0. So yeah, let me say one thing about that. So again, x equals 0 just sets x equal to 0, right? If I want to know, or if I say x equals 5, just sets equal to 5. If I want to know where is the place where x equals 5, I can say x double equals 5, and that's a conditional that tells me 1 where the thing is true, 0 where the things are not true, right? So I can say something like, okay, now take the places where mod x of 3 is equal to 1 and turn those things into 0, right? So now I've kind of taken every third element and turned it into a 0 with a pretty simple command. And then I could say, okay, now I'm going to divide, I'm going to say 1 over x. That gives me an error because 1 is a scalar, x is a vector, so I really have to use 1 dash this. Then I say that, well, if I divide by 0, I get a bunch of places where things were infinite, right? Then there's a nice command called isinf that can kind of tell me where that happened, right? So I can say, where are the places where y is infinite? It's a conditional vector that tells me where things went wrong, right? And if I wanted to say, okay, well now take those places where I messed up and, just set them equal to 0 again, right? I can say that. All right, so it's just kind of like little bits and pieces of MATLAB stuff. And there are similar things. There's isnan, isreal, things like that. Finally, one thing operationally that we use a lot is solving matrix equations, right? So if I have a matrix like this, and I have a right-hand side, and I want to solve AX equals B, right? So you guys learned about Gaussian elimination and all that stuff, right? MATLAB does all that in one command with backslash, right? So if I say A backslash B, I get the answer to that linear system in one shot, right? Definitely we're going to use that, right? That's very handy. And even handier is, a lot of times in signal processing, you're solving problems where your matrix equation isn't square, right? So suppose that I have some sort of matrix equation where I have more equations than unknowns, right? So here I've got matrix, and here I've got a vector. If I try and solve AX equals B, I can't do it because I only have two independent variables and I've got three equations. So I've got three equations and two unknowns. Unless I got really, really lucky, I can never solve those exactly. If I say A backslash B, I still get an answer, and that answer is what's called the least squares solution to the linear system, right? So again, if you go back to your linear algebra or I guess maybe you learned it in IEA, something like that, then you know that there's this A transpose A inverse, A transpose B. MATLAB does that for you automatically, right? Because MATLAB is a tool that's made for linear algebra. And so it's nice not to have to write your little code to solve a linear least squares system. All right, let me pause for breath. So any questions about any of this kind of nuts and boltsy stuff? Yeah?
Not a question, but could you put it on the right screen?
Could I put it on the right screen? Yes, I can do it. Sorry about that. That's an easy question. Sorry. All you guys were shafted. My mistake. All right, but we're not done yet, so there's still MATLAB to go. So, again, like I said, common complaint is I never learned about MATLAB, I don't know how to use it, and this video is the only resource I have. That's not true. So, for example, if I were to, say help backslash, right? I think it's help slash or help backslash. Right, so here I get a little bit of a story about what that command means. Again, since my screen is so big, I can't read it all. So one thing that's also useful is to say doc slash, right? So here I get basically a web browser like help file. This is actually a very handy code browser. And so let me try that again with something else. So let's say something like doc Lin Space, right? So here, this tells me exactly how to use that command. So if I, make a mistake or I don't remember what order to give variables, that's what I can use. And also, if I don't really know exactly what I'm looking for, so, I can also look for, I'm not sure this will work. I can also look for commands that contain the text that I want in their help text, right? So if I know kind of what I'm looking for, but I don't know if it exists, I can certainly kind of look for something, and it goes through the whole help tree to find things that contain that. So you can see that, the help text appeared here, right? Generate linearly spaced vectors. That's what, that's what MATLAB is looking for. And like I said, you hear this is a relatively simple command, so there's not that much to say. If I ask for something more complicated, like, of course, now I'm drawing a total blank on this. So I'm going to talk about this function pulsetran later, which is a little bit complicated. Let's see here. No, this is not what I was looking for. I'm looking for something that has some code to it. So, like, how about, whoops, what are we doing here? How about surf? All right. I guess I didn't think about this carefully enough. I'm looking for something that often, if it's something that's got some code attached to it, you'll be able to actually run the code from the browser. It gives you some examples. And maybe as we're doing stuff, I'll come across something that happens. So basically, help, look for, doc, all is good. And certainly also you can Google stuff, right? I mean, MATLAB has all the help files online, so you can just find it online. But your installation, if you have a legal installation of MATLAB, you should be able to get all this stuff innately. So, okay, so this is all stuff that's kind of like command line-y kind of stuff. Here's some stuff that you may not know. So one thing that I could, so I can talk about functions and scripts, right? So I write a lot of functions, and so there's a built-in Matlab editor So if I want to save a bunch of commands, right? So I could basically, write my code, and then I can, output the result. So if I do this, so let me just save this as, some simple script. So here, suppose I clear all my variables. So here, if I run my simple script again, it's just like typing all that stuff in at the command line. And I apparently made a mistake in that 2-line MATLAB code, so let's go back and see. All right, so apparently this should be x squared, right? Because y wasn't defined. So let's try it again. So if I run this script, basically then it's just like having typed all those stuff into the command line, and you can see, although it's necessarily kind of small, that x and y are living up here in my space, right? But I often like to write functions instead of scripts. The reason being that, scripts will clutter up my workspace with all these random variables, whereas oftentimes I want to, not care about all the intermediate stuff, but just get at the output, right? So I can instead, write a function where I say, okay, this is a function. MATLAB knows that when an M file starts with function, that's a special thing, and square it. I can say something like this, right? So here, maybe I could make this really belabor the point. So I could make some stuff inside this function. So here, I've defined this variable z in the middle. Oops, I guess I saved over my script. So here, suppose that I, take the output of, I put in some vector and square it, right? That means that even though the inside of my function named that variable y, whatever gets, whatever y is called here just gets passed out of the function, and here I said, okay, actually I want that thing to be called g, right? And you'll also notice that intermediate variable z that I made in the middle, even though it was internal to the function, it doesn't come out into the workspace, right? So, I think that that's generally a cleaner way of programming is to make functions like that. So again, something that you probably already knew. For example, if you're doing homework, I think it's generally a good idea to make like a function for every homework problem, right? Then things kind of are nice and clean. You can go back and run that stuff again. Doesn't rely on all the stuff that you had in your workspace. Here's something that you probably didn't know. And so these are called anonymous functions. And so this is kind of neat. So I could also make it almost looks like a variable, right? So I could say something like this. Right, so I have this @ symbol. So when I do that, I get this kind of weird looking thing, right? So here, if I do whos, this kind of tells me what variables I have, and it says that this SQ is not a number or a variable, it's a function handle, right? And that means that SQ doesn't live as a mat file or an M file, but it can be applied to a variable just like one. So if I say SQ of 345, it acts the same way as that M file, right? So if I want to make some sort of a simple M file that can be described in kind of like one line, there's no need to make a whole separate M file for it. You can kind of make this thing that lives in your workspace that acts like it, right? And that actually turns out to be fairly handy, right? So now, for example, I could define, maybe I could define a function that is, some function of t, right? So I could say t squared plus 3 times t plus 5, right? So I can evaluate that function anywhere I want, and then I could say something like, okay, integrate that function. I'm trying to remember how to use this. So actually, let's ask here. So integral is what I want, right? So numerically evaluate integral. So here what I can do, and finally I found a place that has examples, right? So here, if I want to integrate that function, this tells me how I could use it, right? So here's something very similar. I defined a function in MATLAB, and then I could say, okay, integrate this function from 0 to 5. Oops. And it gives me a number, right? So again, you don't have to have Maple or some sort of symbolic toolbox to do this. It's something that's kind of nicely built into MATLAB, right? And so I found that that was pretty handy. And there are lots of once you kind of get used to this, there are lots of very clever ways that you can kind of nest anonymous functions. So for example, suppose that I named some variable, and then my function included that variable, right? Maybe it's actually easier to do this in a more easy to see way. So let's suppose that I make a function that is a times t, right? So now if a is 6, that means I just multiply something by 6, right? If I rename a to something else, that function still remembers that a used to be 6 before I defined it, right? So kind of the function keeps stuff that happened when you defined it and doesn't change it otherwise, right? So anyway, this is kind of fun to play around with. It doesn't come up super much, but I found it to be handy in some programming things. And then let's talk a little about signal processing stuff. So we just talked about cosines and sines, right? So here's like kind of taking stuff we learned. So I'm going to make some sort of, long time vector. Whoops. And then I'm going to make a, 2 times pi times t like thing. I can plot t against x, so I get some sort of a cosine. So one thing that is kind of nice is that sometimes you need to have a pulse, and so there are some ways. Suppose I wanted to take a vector that was kind of symmetric around the origin, and I wanted to make a rectangular pulse that is 1 unit wide, right? So there are a couple ways I could do that. One way is with a conditional, right? So what I could do is I could say, okay, my pulse is going to be, show me the places where t, where the absolute value of t is less than 0.5, right? If I plot that, then I'm going to get basically this thing, right? And so plotting, I guess I've been plotting a little bit already. One thing to kind of keep in mind is that there are lots of ways you can change a plot. So here, for example, I can kind of see that it's kind of hard to see where the plot starts and stops. And so one thing that I can do is I can say something like set the, so here's a kind of a plotting under the hood. So GCA is a variable that stands for get current axis, okay? So there's only one axis on this plot. This is a number that kind of MATLAB uses to internally tell how to address plots that are on the screen, right? So I can do something like set GCA, the y limit, to be from minus 0.1 to 1.1. If I do that, then I can change the scale of the plot, right? So the point is that everything about the MATLAB plot is entirely changeable, and they're all controlled by these axis properties that, again, you can do doc, doc axis. Oops. And I believe this will get me to yes, axis properties is what I want. So here I can see there's like a zillion things that I can change with respect to the axes, right? So you don't want to mess with lots of this stuff, but you can do some pretty cool things related to making like a GUI, right? You can kind of change what happens when the user clicks on the axis, but certainly you can change the size of things and so on. And I can also get that kind of control through these menu items. And I have to say that I'm an old school MATLAB non-graphical guy, so I don't actually use this stuff that much. But there are a lot of ways to change what's going on in the plot, right? So here, I think that I can actually just like click on stuff, and I could change the thickness of the line. I can do this either from the command line, or I can do it from inside here. And so I can put markers on here if I wanted to. I can put little circles, right? And so on. Maybe I make these circles a little bit smaller. So basically, you can change anything about a plot from either this little plot debugger thing or from the axes properties. And so, again, just when you think about, since I'm doing all the MATLAB stuff online this semester, you don't have to hand in plots with your homework anymore, but certainly when you're handing in plots to anyone, you should kind of think about how well they look, or how good they look, right? So try to make your plots look nice in general. That's a good thing. There are some 3D plotting functions, like plot3 and surf and stuff like that. When we start to talk about 3D stuff, we'll get there. Another handy MATLAB trick is, there's a command called eval, right, which does nothing more than evaluate what you put into it. And so you can use this to kind of procedurally generate strings and titles and stuff like that. So let's suppose that I make a little script and then say, okay, for I equals 1 to 5, what I'm going to do is I'm going to eval this statement, which says make a variable that is, so first I'm going to make a little string, right? So I can say that string is made up of Q, the string equivalent of this number, and then something like this. So this is my statement. And then I could say eval statement. So let's see what happens here. Right, so these are the statements that were generated, and you can see that kind of procedurally as I went through the loop, it made a bunch of variables called Q1 through Q3, and it named those variables correctly, and then it added, so I can see that Q1 is equal to 1, Q5 is equal to 5, right? So this is actually pretty handy for, especially when you're generating, text files or output that you want to save, and you want the output to be saved according to, what loop entry you were in, stuff like that. This can be pretty handy. Okay, so let's put it all together and do some signal processing type stuff, okay? So let's close all, clear all. Okay, so those of you, I guess, that I've probably talking to the wrong crowd here, but it used to be when you picked up the phone, you get a dial tone, right? And you used to get a ring and a busy signal. I'm not sure you actually hear those sounds anymore on cell phones. But it turns out that those types of sounds are just made up of cosines of different frequencies, okay? And so what I'm going to do is I'm going to make a time vector, okay? So don't worry too much about the spacing. I'm just going to choose a spacing of, say, there's an example of using, I should use a semicolon, right? So then I get this blarg output. So here what I'm making is a time vector that's very finely spaced between 0 and 4 seconds, okay? And it turns out the dial tone is made up of two cosines, one at 350 hertz and one at 440 hertz. And so what I'm going to do is just make a signal that is, here's the 350 hertz cosine, and here's the, well, first let's hear this, right? So here's one of the cosines, and if I do sound of the sky, and this fs just tells me how far apart the samples are. Oops. I guess I have to turn my laptop sound up. So that doesn't sound like something you hear on the phone, maybe if you're in Europe or something. But if I combine this with a cosine of a different frequency, then I'm going to get a kind of a more familiar sound. So that's the dial tone. So it's very different, just adding two cosines together, right, can sound quite different. And so now, suppose I wanted to make, the ring signal is 440 hertz and 480 hertz. So if I hear that, okay, but this is like a continuous ring, right? So suppose I want to now make it actually sound like it's ringing, right? So now what I want to do is I want to multiply that by a pulse train, right? So kind of what I want to do is I want to take that cosine and put an envelope on it that looks like a pulse, kind of turns it on and off. And so it turns out that there is a function called pulsetran, right? So if I do help of pulsetran, I can kind of see, whoops, maybe I'll do doc of pulsetran. I can kind of see that this is exactly what I want, right? So what I do is I can supply a time vector and I guess here I can actually generate pulses that are triangles. What I want is a pulse that's a square, right? So let me see. I want to supply a time vector, I supply the places where the pulse occurs, and I specify the function that I want, right? So let's suppose that I make a pulse that is pulsetran. So I'm going to use, I guess my time vector was between 0 and 4, so I'm going to say same time vector. And where do I want the rings to occur? Let's suppose I want the rings to occur every, half a second, or every second, spread out a little bit. And then I'm going to generate my pulse tran with rectangular pulses. You can see here that Matlab is helpfully popping up for me the help syntax for the function, so I kind of remember what order things need to be in. And then let's say I want these pulses to be like a quarter or half a second wide. So now if I plot what I just made, it looks like something that is on and off. Again, so here's a case where I want to make sure that's kind of more visible, so I'm going to set the limits to be a little bit better. So you can see this is a pulse that kind of turns on and off, and now I can see that I've got my pulse vector and my y vector, and if I multiply these together, I should be able to get the sound. If I multiply them together like this, yes, dot times pulse, right? So now if I do sound of ring, like this, I guess it's more like the busy signal, actually, right? In terms of the cadence. So actually, I can do the busy signal, too. So if I go back and I change my Y to be 480 and 620, and multiply these things together again. Right. There you go. So again, the wonders of Matlab, right? So now let's talk about this coding thing. So let me pause to ask. I've been kind of blathering on. So questions or comments about anything I did so far? Yes?
Quick question about using functions.
Yeah.
In a function, can you use plot and evaluate, and then obviously, well, first of all, can you use evaluate as basically a print statement?
Yes.
Okay.
Yes. I mean, print statement also, I mean, like, if I just want to display an intermediate value, I can use disp. Right. Well, I guess I don't have X defined. But yes, I mean, the only reason to use eval over disp is when you've got some sort of variable inside that you can't predict the name of, right? So basically something that's more procedural, right? So eval is for more, clever string processing, and disp is just for showing the name of a variable.
Okay.
Yeah.
And you can use those in a function and just call the function and it'll do it all?
Yes.
Okay.
Right, for sure. Other questions or comments? Okay. So now you're all MATLAB experts. So now I want to tell you how you're going to use this Cody thing to do the MATLAB problems in this class. So let's take a look. So I sent myself an invitation. So hopefully you guys all got similar invitations to this Cody thing. So you should have gotten an invitation that kind of looks like this. I guess it looks like it comes from me, too. So first thing you have to do is make a MathWorks account. I've been invited to run the course. I don't think I have a MathWorks account, so I just sign up for one. United States. I guess this is not me, actually. I have to be the butter passing robot. So I already forgot what I was here. Is it butter passing or butter pass? Butter passing robot. Okay. See, butter passing robot without the one was already taken, so I was. Okay. All right. United States. How will I use it for student use? I'm 13 years old. Go back to here. Wait for it. Actually, I guess I was wrong. I thought that there was a place where I also had to specify what school I was from. Did you guys see that? If any of you did that? No. Okay. Verify email address. Okay, here we go. Verify my email address. So this is very much like what you're going to see. Oh, here's where I do my, what is my purpose? Password doesn't matter. Okay. Oh, come on. Ah, you suck. You suck. You suck. Okay. What describes my role? I'm a student. I guess I'm an undergraduate student. Department, electrical engineering, school. Whoa. So I believe there should be an RPI thing in here. Come on. Don't. Well, for the sake of argument, I guess we could be from somewhere else, but I guess that we should be honest. Okay, it found us. Good. So see your counter license. Don't worry about this. This shouldn't matter. Just leave it blank. All right. Could not enroll me. So I got this before. Don't freak out about this either. So now, after I get to this point, what I would say is go back to your Gmail and click on the invitation again. I think there's some sort of weird bug where it doesn't let you enroll the first time. So now I'm enrolling. Okay. So now you can see here, and I'm going to make this a little bigger, that there are 2 homework problems, or 2 homework assignments, right? The first one doesn't really matter. I'm just going to do that in class right here, just to show you. So here, this is the interface that you're going to see. So here, there are 2 problems in this assignment. And if I click on the assignment, I see the description that tells me what I want to do, right? So I want to just make a sinusoid, right? And here, I helpfully included a picture. This says, okay, I need to specify the amplitude, the frequency, the phase, the interval, and the number of samples, right? So here, I need to make 2 things. I need to make a time vector, and I need to make a sinusoid. And so, okay, I kind of see, I get the gist of this. So now I hit solve, and you can see here that there are a couple things to look at. First of all, there is a template for the solution, right? So here I've helpfully kind of given you what you need to fill in to make this work. And then you can kind of see that down here, there is a test suite where your solution is tested against something that I've written to make sure that you're doing the right thing, okay? And so here I'm testing for making sure you have the right time vector, making sure you have the right sinusoid, and also there are some hidden tests that make sure that you didn't game the system, just put in the answers that I told you for the visible tests, right? So this is a pretty easy one, so let's just see here. So I need to make this sinusoid starting at 0, n samples separated by t, right? And so let's just start typing here. So I want to start at 0. I should be separated by 1 over t, and I want to have n samples, right? So I guess I can say that the last sample should be n minus 1 times 1 over t, right? That seems about right. And then I want to compute the sinusoid, which, if I did this correctly, should just be like a times sine of omega times t plus phi, right? So that seems pretty reasonable. And now I can test it. I hit the test button, and now it goes off and runs things, and it tells me my time vector and my output vector are incorrect. All right, so maybe I should think about what went wrong here. It's kind of embarrassing when you get the problem wrong. All right, so here's a case where actually one thing I advise is that it can be difficult to write these answers for the first time inside this box on the web page, right? So what I do recommend is actually trying to write this on your own. So what I would say is let's copy the thing over here, and I want to make a version of this to test on my own in my own directory, right? So here, instead of trying to debug this online, I'm going to try and figure out what went wrong over here, right? So now I can try and say, okay, what was the test trying to give me, and what did I actually get, right? So the test was asking for this sinusoid, and I failed, apparently. So what do I get? So let's look at my time vector, because it seems like the time vector is the problem. So the test is asking me for, it's kind of trying to test what is the value of t at 150, and it says 2.98. So what is my value of t here? Well, this is like way off. What did I do wrong? So now I can look back at my sinusoid and say, okay, so I think the problem was that when I did this syntax, right? So it was like this, right? It was saying t was 0.02, and I think my problem was that I said 0, 1 over t, and then I said what? N minus 1 over t? I think this is just like a thing like this. So let's suppose I do this. Now I've totally confused myself. this is stupid. Okay, so let's go back here. I don't need to use MATLAB to fix this, right? Because I'm supposed to be separated by t, not 1 over t. I don't know why I did that. Stupid. Okay, let's see how this goes. That didn't look so good. Let's go back here. Try again. So this is still a work in progress in terms of okay, pass. And I can see actually that I get green checks if I submit this. I should see something that tells me I did it right. Right? So this tells me that I get a green check mark that says I did it right, and I can see that I passed all the visible tests, and even though you don't know what tests I devised in the hidden tests, it also passed those. So you did the problem right. So at that point, you're done, right? There's no need to do anything else. Let's try this other problem. This is a little bit more complicated. I got to read the problem. So basically, this is saying that if I add up a bunch of sinusoids that have the same frequency but different amplitudes and phases, I should get back basically some other sinusoid that has the same frequency. But I have to figure out what the amplitude and phase of that sum is, right? So kind of what I'm doing is I'm taking the input vector is the amplitudes and phases of the component sinusoids, and the output should be just the single amplitude and single phase of the sum. And it tells me I actually have to know what the frequency of the sinusoids is. All right, so let's see if I can solve this problem. I'm going to switch over to my paper and pencil for a second. And I apologize that those of you who are watching this video at home can't see what I'm writing, but I'll talk out loud. So what this is saying is, okay, my hypothesis is that if I have a whole bunch of sinusoids, so say I've got, like A1 cosine of omega 0 t plus phi 1 plus ... AN cosine of omega 0 t plus phi n, that's going to equal some sort of cosine at the same frequency with some unknown amplitude and phase, right? So let's think about why that's true. Well, first of all, I'm going to kind of turn this into something that's a little bit more exponential, right? So here I can see that, actually this is like the real part. So what I want to look at is I want to look at the sum from I equals 1 to n of AI cosine omega 0 t plus phi. Okay? And I can see that actually that's the real part of this guy here. Okay? And now what I'm going to do is I'm just going to kind of try and add these guys up, right? So inside the sum, I've got AI, e to the j, cosine omega 0 t, e to the j, phi. Now I'm going to, the way I did this, I can see that actually the only thing that depends on I is the stuff here. Right? And so this is just some complex number, which I'm going to call A tote e to the j phi tote. And if I kind of put this back together, I'm going to get something like this. Oops. There's no cosine here. This is like this. No wonder I suck at this. Okay. Right. And then I can see at the end of the day, what I have is, you know, a tote cosine of omega 0 t plus phi tote. Right, so kind of what I'm getting at is that all I need to do is take whatever these complex numbers were, add them up, and that's going to be my a tote phi tote. Right, so let's see if that works. So let's see here. Convert the n-input phasors into complex numbers. So that means that I'm going to take my complex numbers are going to be a dot times e to the j times phi. So these are both vectors, right? So I can just do this thing. And then I'm going to just add up those guys. And then I'm going to let my a sum be the absolute value of this, and my phi sum be the angle of this. Let's see if that works. Pass, pass. I guess I have to submit it to see if it actually works. And don't worry if you don't get it right the first time, because you can improve your solution if you don't get it right. So what I'm going to see when you submit this is basically for each of the little subtests, yes or no answer, right? And then if you get it all right, you get a check mark for the whole problem. And so you keep on trying until you get it right. And let me just kind of do an example here. So let me just show you the whole point of the hidden test is here. What I'm doing is I'm testing in the visible tests something you can see to make sure it works. And so what I could do if I was kind of sneaky would be to say, okay, actually, forget all this stuff and just try and, let me try to improve my answer. Yeah. I think my touch screen is like playing havoc with this. Okay, so let me try improving my solution. I could really improve it by just trying to game the answer. So suppose that I were to just put in the answer. I know that you're looking for 10, and I know I'm looking for, what was the other value? 0.9273 or something like that. Okay, so let's see how that goes. So this should pass the visible tests, but if I submit it, it'll fail the hidden tests. Right? So here I'd have to try again. That's the whole point, is every problem has some hidden tests to make sure that you're actually solving the problem. So in theory, it should work pretty well. I will say that this system means that, number one, the TA doesn't have to go through and try to figure out whether some code is right from looking at pages of a printout, right? So I think that will save everyone some time. The downside is that basically the problem is either right or wrong. So there's no partial credit. Either you get the test right or you get it wrong. So there may be some partial credit in terms of how many of the tests you get correct, but fundamentally, there's no kind of nitpicking about, oh, I put an I here when I should have had a J. It's just going to be, strikes and hits, right? So again, Piazza is a good place to ask questions for, okay, so questions already, yes?
Are we allowed to submit multiple times?
Yes, you can submit as many times as you want until you get it right.
There's no points to talk to?
No.
Okay.
I will not, so basically the window for submission closes at 10 o'clock on the day the thing is due. You can submit and refine and improve as many times as you want up until then. Same question, okay. Yeah?
Well, after the due date of 10 a.m.,
Yeah.
can we see the hidden test cases so if we didn't get them right, we can figure out why?
Good question. There's no way for me to directly expose the hidden test cases to you through this, but I can talk to you about it
So if we
afterwards.
don't have them right, we come see
Yes,
them.
that's right. So I ask you to bear with me on this. This is a new thing that I'm trying. I don't know how it's going to work, but I do think that, I do like to make sure you understand how to actually code this stuff up. And so this is kind of a trade-off between more MATLAB and easier for people to grade. So, all right, so everything should be visible to you now. You should be able to see what the homework number 1 looks like. And so there are 3 problems. Get started. Monday is Labor Day, right? So I'm not going to see you again until Thursday. But I'll be watching Piazza